A compass is an instrument designed to indicate direction on the surface of the Earth, relative to some known datum. The magnetic compass uses the horizontal component of the Earth's field as its directional datum. Unfortunately, the Earth's field is normally not aligned with a true meridian, the most desirable datum from which to measure direction. The angular difference between true and magnetic meridians is called the magnetic variation. The purpose of a magnetic steering compass in an aircraft is to indicate heading, the direction in which the aircraft is pointing. Magnetic influences, iron or steel components, electric currents, distort the Earth's field so that the compass magnetic assembly deviates from the magnetic meridian. This is called compass deviation. The rules for applying variation and deviation to the compass heading indication in order to determine true heading are discussed later in this lesson. This part of this lesson deals with the direct indicating or direct reading magnetic compass, where the pilot directly reads his heading in relation to a pivoted magnet assembly. There are two basic types of direct reading magnetic compasses used in aircraft: the vertical card and, less commonly, the grid ring compass. The vertical card compass, which is also known as the B-type or E-type, is a direct reading compass in general use. It's usually the main magnetic heading reference in light aircraft, and the standby compass in larger aircraft. It consists of a circular compass card attached directly to the magnet assembly. This combined unit is suspended in liquid within the compass bowl. A vertical lubber line on the glass window of the bowl enables the heading to be read off the compass card. The P-type compass or grid ring compass is found on older aircraft. It's more accurate than the vertical card compass and is more stable. It is, however, heavier, bulkier, and more expensive. In addition, it can only be read in straight and level flight, as the grid ring has to be unclamped and aligned with the north reference before a reading can be taken against the lubber line. The grid ring compass also differs from the vertical card compass in that it achieves a greater periodicity by the addition of damping wires, which also rotate through the compass liquid. The Earth behaves as though a huge permanent magnet was situated near its center, producing a magnetic field over its surface. The direction of that field at any given point can be indicated by a freely suspended magnet. Such a magnet will align itself roughly in a north-south direction, with its red pole toward the north magnetic pole. However, the poles of the Earth's magnetic field do move, and are seldom coincident with the Earth's spin axis. The position of the north magnetic pole is moving at almost 10 nautical miles per year, and since it was first located in 1831, it's moved approximately 625 miles, and is presently close to Ellefringnes Island in the Canadian Arctic Islands, which are 650 miles west of the geographic North Pole. That would make the magnetic lines of force lie like this, and the freely suspended magnet will align itself like this. The angle, measured in the horizontal plane between the magnetic meridian at a point and the true meridian at the same point, is known as the magnetic variation. Variation is designated west or east, depending on whether the magnetic pole lies to the west or to the east of true north. Variation can have any value from 0 to 180 degrees, the latter occurring on the true meridian, linking the north geographical pole with the north magnetic pole. A simple rhyme can be remembered which will help enormously in working out which way to apply variation to your heading. Variation west, magnetic best. Variation east, magnetic least. Here, an aircraft is flying due east by reference to points on the ground. So, if the variation is west of true north, say 11 degrees west, then add it to your aircraft's true heading to get your correct magnetic heading of 101 degrees. Conversely, if the variation is east of true north, say 11 degrees east, then subtract it from your aircraft's true heading to get your correct magnetic heading of 079 degrees. Remember, variation west, magnetic best. Variation east, magnetic least. Except near the magnetic equator, where the lines of force are parallel to the surface, one end of the freely suspended magnet will dip below the horizontal, pointing to the nearer pole. To the south of the magnetic equator, the magnet's blue pole will be lower, whereas to the north, the red pole will be lower. The angle, measured in the vertical plane between the axis of the magnet and the horizontal, is called the angle of dip. If the freely suspended magnet is moved either north or south of the magnetic equator, the dip gradually increases, reaching about 66 degrees in the United Kingdom. Over the Earth's magnetic poles, the dip is 90 degrees, and the magnet is then vertical. During a turn, the liquid in contact with the inside of the compass bowl tends to be dragged around with the bowl. Therefore, the liquid tends to swirl and rotate the magnet assembly with it, in the same direction as the aircraft's turn. Direct reading compasses are subject to large errors during linear acceleration or deceleration, or during a turn. Turning and acceleration errors only occur where there is significant magnetic dip, so that except for a small liquid swirl effect in turns, the errors are non-existent near the magnetic equator. This diagram shows both the top view and the pilot's eye view of a pendulously suspended magnet, with residual dip, in the northern hemisphere. Note that while the aircraft is in cruising flight, the compass reading is correct. The magnet is attached to the aircraft at the pivot point. However, while the pivot is being accelerated, the magnet will try to stay where it is because of its inertia, which acts at the magnet's center of gravity. The result will be that, even though the aircraft is flying in a straight line, the magnet will rotate, in this case anti-clockwise, and the incorrect heading will be shown. Notice that once the aircraft is in cruising flight and the acceleration has finished, the magnet moves back to its original position and once more shows the correct reading. Turning errors are maximum when turning through north and south, and ignoring liquid swirl, 0 when turning through east and west. The error increases with increase in magnetic latitude. At the magnetic equator, the only turning error is due to liquid swirl. Whenever the pilot turns through the nearer pole, that is the North Pole in the northern hemisphere or the South Pole in the southern hemisphere, the aircraft and compass rotate in the same direction, and the compass will be sluggish. The pilot should undershoot the turn. That is, he should roll out early. Whenever the pilot turns through the further pole, that is the South Pole in the northern hemisphere or the North Pole in the southern hemisphere, the aircraft and the compass rotate in opposite directions, so the compass will be lively. The pilot should overshoot the turn. That is, he should roll out late. Select any of these buttons to see how turning errors affect the compass. Deviation is produced by the iron, steel, and electrical components of the aircraft. It's the angle between the local magnetic meridian and the direction in which the compass magnets are lying. Deviation is named easterly or plus if the north-seeking red end of the magnet points to the east of magnetic north. If the north-seeking end points to the west of magnetic north, deviation is said to be westerly or minus. Deviation varies with heading, so it has to be measured on a series of different headings. This is usually done by conducting a compass swing. Once deviation has been reduced as far as possible, the residual deviation is recorded on a compass deviation card, which is located in the aircraft. During the swing, normal flying conditions should be simulated as far as possible, with engines running, electrical and radio services switched on, and the aircraft in a level flight attitude. It's obviously most important that no ferromagnetic objects such as tools or watches should be placed near the compass, as this would introduce unknown amounts of deviation. Here we see that we are flying with a compass reading of 270 degrees. The compass reading is the magnetic heading plus or minus the deviation on that particular heading. The deviation card makes it easy for us to fly an accurate magnetic heading. In this case, it's telling us that to fly on a magnetic heading of 270 degrees, we must steer 269 degrees. The basic method of determining deviation is to compare the aircraft's heading compass reading with magnetic heading, as defined by a high-quality land or datum compass. This comparison of aircraft compass and magnetic datum readings is carried out in an area selected specifically for this purpose. Major compass errors are corrected by adjusting small magnets mounted in the compass system. Any residual errors that remain are shown on a compass deviation card displayed in close proximity to the compass in the cockpit. There are several occasions when an aircraft might require compass swing. Among these are when compass components are installed or replaced, whenever the accuracy of the compass is in doubt, after a maintenance inspection if required by the schedule, after a significant aircraft modification, repair or replacement involving magnetic material, if the aircraft has been struck by lightning. Check that there is no obvious damage to the compass body such as dents or cracks. Any lighting system should be checked, as should the efficacy of luminous paint. The compass liquid should be checked and be free from sediment and discoloration, either of which would indicate corrosion, which would result in increased pivot friction. The compass liquid should also be free from bubbles, which would probably indicate a leaking seal. Turbulence and maneuvers would cause any bubbles to move about, creating eddies which could disturb the magnet system. The compass reading can also be checked for gross errors when you first enter the aircraft, and make sure that the compass deviation card is placarded conveniently close to the compass. Check the compass reading while taxiing the aircraft. Remember, the compass reading should decrease when you're turning left and increase when you're turning right. Just before takeoff, check the compass reading against the runway QDM.